Okay, this is Professor Dam. I'm going to show you how to find the correlation and regression using SPSS. I have some fake data here that I made. I have information for the number of cups of coffee people have and how long they lived. Again, this is fake data. The first thing you want to do is make sure that both these variables are continuous. I'm going to go to variable view, and you see they're both marked scale. If one of these were marked nominal, it wouldn't run the data analysis that we need. But they look good to us. We're going to click on Analyze, Correlate, and in this case, we're going to do a bivariate because we're just looking at paired comparisons. We will send both of them over to our variables and click OK. And you can see from our output, I just want to make sure you can see it. I might have eliminated your view. Sorry, I apologize. Okay, so you can see from our output that we have a correlation between the cups of coffee people drink and how long they live. We can see that they are correlated at a 0.899. That is significant. And it is also above the 0.5 threshold that we use as a rule of thumb. So there's a correlation there. Now we're going to run the regression. Click Analyze, Regression, Linear. Your view may change a little bit because I'm using the full academic version of SPSS. You might be using a student version, but you should have the same options, I have a few more. Click on Linear. So we have to think about, based on the story that was given in the prompt, which one of these is the independent variable, which one is the dependent. Based on this idea of chronological order, I would suggest that we are saying the cups of coffee came first as our independent variable, leading to our outcome of years living. So that will be our dependent variable. You want to make sure you're clear on which one is the X and which one is the Y. We'll click OK. So from our data, we can see that here is the correlation of 0.899. Remember, this is the model for the entire analysis, so this one is not going to have a negative sign if it is negative for our paired comparisons. Here is our R-square, so our coefficient of determination is 80.7% of the variability in years living is associated with the variability in cups of coffee consumed. And then down here we have the variable or the constants, coefficients that we need for our regression equation. So we can see our slope is going to be 10.6, and then our y-intercept is going to be 59.25. The other thing I want to point out is the standard error of estimate, which we will also need in discussing how wrong we are in our predictions. If you're not a big fan of this approach, let me show you how to use the graph formats to get the regression line. We're going to click on Graphs, Legacy Dialog, scroll down to Scatter Dot. We'll leave it at the default, which is simple scatter. We had just discussed how we had to know which one's our X and our Y, so we're presuming that years living is our Y, our outcome, and X is our cups of coffee consumed. Click OK. Now we have a scatter dot. In this particular case, it looks somewhat curvilinear. That's just because I was faking the data. So we'll go ahead and move forward, but you want to make sure you keep an eye on whether it's curvilinear or whether it's a linear program. If it is curvilinear, you'll want to stop now and not move forward. But let's just go ahead and finish this pretend data analysis. To get the line, we're going to double click on the graph. We're, I hope you're still seeing this. Maybe not. Hold on, let me make sure. Okay, I think I fixed that. So now you can see when I've double clicked on the graph, I get this new pop-up window. I would like to fit a line. So you can use that using the icons if you're familiar with the icons. If not, you can click on Elements, Fit Line at Total. And we can leave it to the default because we are using linear in this classroom, or in this class. And so you can see that it has also given us the coefficient determination, and it has given us the equational line. It looks slightly different than y equals mx plus b, but it's still the same equation. The one thing I will make sure you want to add when you're giving this to me is the y hat equals, and here we have the y-intercept is 59.26, plus the slope 10.64 times x. So these three systems that we used help us get the correlation, the equational line, the standard error of prediction. So if you need all of those pieces of information, you'll need to do all of those three steps, or the last one, the graphical format, you don't have to do if you are okay getting your coefficients from this output here. So you can see the 59.259 here correlates or overlaps with the equational line 59.26 here. All right, let me know if you have any questions.